This video covers everything we did in class today on Tuesday, March 15th. The first thing is the do now, where we practiced multiplying and dividing positive and negative fractions. Go ahead and pause this video, open up ClassKick, and complete today's do now. If you want to check your work for the do now, you can open up the file that's in today's main folder. That's just the classwork notes for today. We are going to move on to the next slide, but I do encourage you to check your work to make sure you have these questions correct. What we did today was on whiteboards. We practiced solving 1 and 2 step equations, which was the learning target from yesterday. What I want to do in this video is I want to show you a few examples of the types of questions that you'll be asked to solve here. I'm not going to solve the exact questions, but I'm going to show you the types of questions. So for example, let's say we had a question like negative 22 equals 2x. We know that we're trying to figure out what number x is. And for a lot of us, we might look at this question and say in our head right away, well, I know that 2 times negative 11 equals negative 22. So I know the answer. But what we're going to be practicing is a more formal method for solving equations, which is to do the same thing to both sides. So if you know that on the right side of the equation, you're multiplying x times 2, we can undo this multiplication or reverse the multiplication by dividing both sides by 2. Now, the reason this works is because if you imagine that you have two groups of x, kind of like how we used to have them on a hanger diagram, if you divide those two groups of x by 2, you're basically just splicing in half. And so your answer is x, because if you split it into two groups, each group would have one x. And so in our problem, we know that we end up with x on the right side is equal to, and remember yesterday we talked about whatever you do on the left, you have to do on the right. Whatever you do on the right, you have to do on the left. And so we need to divide the other side by 2, negative 22 divided by 2. And so x is equal to negative 11. Negative 11 is x. Now, notice that to solve this equation, I did the same exact operation on both sides. And I drew this line right underneath the equal sign to remind myself that I have two sides to this equal sign, it's balanced, and that I need to do the same thing on the right as what I'm doing on the left. Let's take a look at something a little bit more challenging, like what you'll be encountering on slide 3. Let's say, for example, that I have negative 2x plus 3 equals negative 5. In these sorts of situations, you can't get x by itself in only one step because you need to get negative 2x alone first. And so I'm going to draw my line underneath the equal sign again. And again, my first goal is to get this negative 2x by itself. And so I'm going to subtract 3 from both sides. And the reason is because if I take away the 3 from both sides, then I end up with only 2x or negative 2x left on the left side. That's all that's remaining because I took away 3. And of course, if I take away 3 from the left, I need to take away 3 from the right. And so I end up with negative 2x equals negative 8. And now I have something very similar to what we already did on slide 2, which is a multiplication question. And I can go ahead and divide both sides by negative 2, because if I divide negative 2 by negative 2, I end up with just 1x. And if I divide negative 8 by negative 2, I end up with x equals 4. Now we can always go back and check to make sure this makes sense. If x is 4, then I know that negative 2 times 4 is negative 8 plus 3 equals negative 5, and so I know this is the correct solution. And so this format that I just showed you in these two examples on slide 2 and slide 3 is exactly what I want you to do in your ClassKick for questions A, B, and C on slide 2 and questions D and E on slide 3. If you have any questions about how to complete these problems, please make sure you send me an email.